In this video, we're going to talk about contingency tables, which are also sometimes referred to as two-way tables. And so the first thing we need to talk about is, what is a contingency table? Or what is a two-way table? We need to understand what it is in order to talk about it and use it. But a contingency table is a special type of a frequency distribution table that allows us to represent two variables simultaneously or at the same time. And so what it does is a contingency table helps us to summarize the relationship between two qualitative variables. Now that's important to note, that you're dealing with qualitative variables, which, if you'll recall, means you're using words or phrases or categories. And what we do is called it, you get the word two-way because you have information that's represented on the rows by one of the variables, and then you also have information that's represented in the columns. So you have two ways that you're showing the information, and you have two variables. One variable is on the row, the other variable is in the columns. And I want to kind of show you what the setup would look like in just a minute. But let's talk first about who uses this. Why do you care? Why do we need to talk about contingency tables? Contingency tables are used across a number of different industries and businesses in survey research, business intelligence, even within engineering and scientific research. One of the primary uses, and that's going to be our focus, is we're going to look at how to use it related to probability theory, typically in relationship to conditional probability, but also it can be used for varying tests. We can use it for the chi-square test for independence, as well as the chi-square test for homogeneity. And we'll won't talk about those two type tests in this course, but you will be talking about those in later courses. So this will be some background information that you may need. So this is the format of a contingency table. You have information, and I'm going to turn this down for a second where I can draw on it for you and kind of make you some notes as we go about the contingency table. Okay, so notice that in this case we're looking at perhaps gender and then your political affiliation. Again, both of which are qualitative variables. So we're looking at gender in relationship to the political affiliation. And it doesn't matter which one you put on the rows and which one you put in the columns. As the researcher, you could set it up however you wish. You're not limited to 2 categories or to 3 categories. You could have 100 categories, or you could have 50 categories. But the setup is always the same. You have one of your variables that will be in the columns. Okay, in this case, that's our political affiliation. And sometimes you'll see kind of in the corner here, they'll put gender and political affiliation to kind of give you the sense of what information is there. You'll have numbers in each of these columns to tell you. For example, this cell, if you will, would tell you how many females are Democrats. If you went to the cell here under this column, that would be the number of males who are Republicans. And then, of course, you have totals for each of those. And then your grand total, which is this last box over here in the corner, should always be equal to your sample size. And so that's a good way for you to double check that you didn't miss a data value, or you didn't maybe misadd or miscalculate something, is that your grand total should always equal the sample size. And so I want to kind of show you how to use a contingency table. It's not a difficult format to understand, but let's look at how we can use it as it relates to probability. So we have a question. It says, a pizza delivery company classifies its customers by gender and location of residence. The research department has gathered data from a random sample of 1,585 customers. The data is summarized in the table below. Okay, and so you have a contingency table there. Notice one of the first things you want to do when you look at a contingency table is look to see what information is on the rows and what information is on the columns. In this case, in our rows, we have the residents, whether they live in an apartment, the dorm, with their parents, in a sorority or fraternity house, or other. And then in our columns, we have gender. Now here again, we could have put males or females as our rows and the residents. Okay, it doesn't matter. But again, the first thing you want to do is make sure that you pay attention to how the table is set up. Now, in this particular table, they haven't done the totals for us. So that's a very easy process, and that's really the first thing we need to do before we proceed is we need to add the rows as well as add the columns and total them up so that we're ready and we have all the information together and complete before we start. So you may want to get a handheld calculator and add these together. You would have 102 plus 115. I mean, it's simple addition. If you want to pull your calculator out, you would type 102 plus 115, enter, you get 217, and then you just fill in the chart. So I know that the number of people living in an apartment was 217. And you could continue that process. Okay, I'm sure that you can add. So we would combine 244 plus 157 that live in the dorm. That gives me a total of 401. Living with parents, you have 63 plus 240. That gives us 303. 169 plus 200 gives me 369. 171 plus 124 is 295. Now here's the thing that's important. Then you want to total that last column, that you want to total the total column, and notice that in the original problem they told us we had 1,585. So I want to confirm that, and again, you may want to get your calculator. So if I enter the totals, 217 plus 401 plus 303 plus 369 plus 295, it should equal the total number in the sample, which was 1,585, and it does. Okay, so I know hopefully I'm on the right track. I didn't make an addition error. So I have 1,585. But I also need to total up how many males were in the survey and how many females were in the survey. And so again, you would just add the columns. We would add 102 plus 244 plus 63 plus 169 plus 171, and that gives us a total of 749. Do the same thing for the females, and we get a total of 836. And again, if I add those totals, 749 plus 836, I should get my sample size of 1585. Okay, so I can do that. I can do 749 plus 836 and I do get 1585. Again, that just assures me that I haven't made a calculation error. Okay, so once again, the first thing you want to do is read the question, look at how the contingency table is set up. If you need to, you want to total the rows, total the columns, and those should equal to your sample size. Okay, so the first question seems relatively simple. What is the probability that the customer is female? So if you'll remember a little bit about probability, that means we want to look at the probability that they're female, and I just need how many females were in the survey. Okay, so if we look at the contingency table, I'm focusing on females, so I'm going to look at the column for females. Okay, and we just totaled that and got 836. So I have 836 females out of a total of 1,585 customers. Now, it's okay to leave that as a fraction, but a lot of folks have difficulty interpreting fractions, so sometimes it's better to convert it to a decimal. So we do that. Again, it's a simple calculation. 836 divided by 1,585, and I get 0.5274. We typically round to 3 places, so approximately 0.527, or if you want it as a percent, 52.7% of the customers for this pizza delivery company are females. All right. The next question says, what is the probability the customer lives in an apartment? Again, in this case, we only have kind of one condition, one thing we're considering. We're considering whether they, live in an apartment. So I can come back over here to my table, find the row labeled apartment, and we totaled that, and we had 217 people who lived in an apartment out of the total number of customers, which was 1585. And again, you could leave that as a fraction, but again, sometimes that's difficult to interpret. So if I go out, I can do 217 divided by 1585, which is about 0.1369. Okay, so be careful here, guys. Okay, you've got a 6. Next door to the 6 is a 9, so I'm going to round up. So I would actually have approximately 0.137 or 13.7%. Okay, the next one is a little bit different because notice it says, what is the probability the customer is a male who lives in the dorm? Now, another way to say this, it would be the probability that it's a male and lives in the dorm. Okay, and so mathematically, when you see that word and, you have to meet both conditions. Okay, so when you start looking at your contingency table, you need to find the cell that contains male and lives in a dorm. And I'm going to switch colors here to try to help you see that. Okay, so I need a male, so I'm going to go to the column labeled males, and they live in a dorm. So the number of students that are male that live in a dorm, and I'm going to underline, make a little star beside this so you know it's the red one. Okay, there are 244 males who live in the dorm. So we have 244 male live in dorm out of, again, the total of 1,585 customers. Okay, and again, we can convert that to a decimal. We can do 244 divided by 1,585, which is 0.1539. Again, be careful because you're going to round up. So it's going to be approximately 0.154 or 15.4%. I hope you remember that to convert to a percent, you simply multiply the decimal by 100. All right, let's look at the last one. It says, given that the customer is a female, what is the probability the customer lives in a sorority or fraternity house? Now, this one is it's not very different, but this is what we call a conditional probability because we've been given a condition. We're told that the customer is female. So we know that that the customer is a female. So I'm only going to focus on the column that represents the female because I've been given that condition. We've set a limitation. We don't want to look at all the customers. We only want to look at the females. It's called a conditional probability. And it usually will start with the phrase given that, or we'll have that phrase in the description. So I'm only focusing on the females. And it says, what is the probability they live in sorority or fraternity house? So then I'm going to come over here. Okay, sorority and fraternity house, and that's 200. So I have 200 that live in the sorority or the fraternity house. Out of, and here's where it's different, we're not looking at the entire data set anymore. We're only looking at the females. Out of 836 females. See, I limit it to the females because I know that the customer was a female because they told me that. We set that limitation. So we have 200 over 836. Again, you can go out and do the division. So if I do 200 divided by 836, it comes out to be approximately 0.239 or 23.9%. Okay, so that's a little bit different. We haven't maybe talked about that type question before, but when you have a conditional probability, you limit or focus only on that group that you know about. All right, let's look at one more example. This one says, a student is interested in whether there is a relationship between gender and major at her college. She randomly sampled some men and women on campus and asked them if their major was part of the natural sciences, social sciences, or the humanities. And her results appear in the table below. Okay, so we have two qualitative variables. We have gender and then we have major. If I'm focusing on the table here, I notice that it appears that my gender, women and men, are on the rows. The majors, whether it was natural science, social sciences, or humanities, are on the columns. And in this particular case, the table is already totaled for us. There were 34 women, a total of 23 men, a total of 21 natural sciences, 22 social sciences, 14 humanities, and the grand total, or the total number in the sample, was 57. Okay, so that might be something that'll be helpful if I point out to you. It didn't tell us in the story how many we had, okay? But I can tell from my contingency table that this was the total number in my sample. So this is my sample size, that the student surveyed 57 students. Okay, so the first question here says, what is the probability the student is a female with a major in social sciences? This word with that you see in some of these questions, another way that it could be worded if you look at those is it could be and. Okay, so just be aware of that when sometimes it says a female with a major, another way to say that is a female and is a major in the social sciences. So I'm looking for both things. So I know I want to look for a female, so I'm going to go over here and look at the row that says women, that's female, and in the social sciences. So I'm going to go under social sciences. So there's a total in that case of 14. So there were 14 females. Whoops, sorry about that. Go up a little bit. 14 females and social science out of the 57 students. Now again, you could leave that as a fraction. Decimals are usually a little bit better understood, so you can do 14 divided by 57. And let me show you that one, because again, you want to be careful about your rounding. 14 divided by 57, 0.2456. Again, the 6 is going to bump the 5, so be careful. It's going to round to 0.246. Okay, so 0.246, or approximately 24.6% of the students that were surveyed were females and had a major in social sciences. Okay, the second one says, what is the probability the student has a major in the humanities given that the student is male? Okay, notice in this question it says given that the student is male. So we know that the student is male. So I'm going to focus just on the row of the table that represents males or men. And then it asks me what's the probability they're a humanities major. So I'm going to look under the column for humanities, and I noticed that that would be 4. So there were 4 humanity majors that are male. Okay, so that's 4 humanities out of the 23 male students. Remember, you don't use the grand total here because you only are considering the males. It's kind of like you're ignoring the women. So you have 4 divided by the 23 male students. So 4 divided by 23 would be approximately 0.174 or 17.4%. The next one says, what is the probability the student has a major in the natural sciences? Notice in that particular question, there are really no limitations. It doesn't say we're going to focus just on natural sciences or anything like that. So now I'm back to using the entire sample size, and I want to focus on just the fact that they're in natural sciences. So in that particular case, if I focus just on natural sciences, I would have 21 total in the natural sciences out of the 57 students that were surveyed. Okay, so you have 21 divided by 57. That's going to be approximately 0.368 or 36.8%. Then the last one here says, what is the probability that the student is male? Here again, I only have one condition, and I want to focus on the fact that they're male or men. Okay, so there were 23 males in the survey out of the total of 57 students. Okay, so 23 divided by 57, again, what's your rounding, is 0.404, which is approximately 40.4%. Okay, so a contingency table, again, is a simple way to organize two qualitative variables at the same time. We're focusing on using it for probabilities. And again, you have to pay attention to the phrasing. Are you focusing on the entire group, or are you focusing on a particular subset of that group? Are you focusing just on males or just on females as you think about working through those particular type problems?